it starts off with an nth term question. So we're looking here for the nth term of this sequence. We're given the first four. So first thing when we're finding the nth term is we need the first difference. So here we've got plus 4, and plus 4. So from this we multiply the first difference by n, we get 4n. And then we do the first term minus the first difference. So the first term is 1, and the first difference is 4. So 1 minus 4 gives us minus 3. And then we add these two bits together. We get 4n minus 3 for 2 marks. Okay. 3 and 4/5 minus 1 and 2/3. Now, before we do this, we need to convert both of these to improper fractions. They're given as mixed numbers here. So, we know that to subtract or add two fractions, we need to make them have a common denominator. So 3 and 4/5, I'm going to convert this to 19/5, minus 1 and 2/3, I'm going to convert to 5/3. Okay, now again, these don't have a common denominator. How do I get that? Very simple. I'm going to multiply this denominator by 3 to get 15. I'm going to multiply this denominator by 5 to get 15. Multiply by 5 there, multiply by 3 there. Now, anything we do to the bottom of a fraction, the denominator, we're going to do to the top to simplify. So I'm going to multiply this by 5 as well. Gives me 25. I'm going to multiply 19 by 3, which gives me 57. 57 minus 25 equals 32/15. And this is my answer. Where he went wrong. So he started here, 2 1/3 times 5/8. Nothing wrong with that. He then converts 2 1/3 into a improper fraction. It looks like he's done that fine. 2 would convert to 6/3, add the 1/3 on, that's 7/3, and he multiplies that by 5/8. So no issues with this line. Everything is done as we would expect. Then he does 7 times 5 for the numerator, which gives us 35. 3 times 8 gives us 24 as the denominator. So this line looks okay as well. And then he converts 35/24 to 1 and 9/24. So let's have a look at this. If we were going to convert 35/24 into a mixed number, it would be 24/24 plus whatever's left from the 24 to the 35, it would be 11/24. So this is his mistake. Okay, on to the next one. Question 3. So question 3 says, we have a diagram of a floor plan and she has 3 tins of paint. So I'm going to underline any keywords I come across or key bits of information. So 3 tins of paint there, 2.5 litres in each tin. She thinks 1 litre will cover 10 metres cubed. So I'm going to put here 1 litre equals 10 meters squared, sorry. Okay, so she wants to know if she has enough paint to cover the whole floor. I'm going to need to work out the area of this floor then. Okay, so for this area, I'm going to highlight that in yellow. For this area, we're going to need to do 8 times 6, which gives us 48 meters squared. And then for this green bit here, I'm going to need to do 4, which is what's left of the 6 here, 4 meters times 5. Okay, if this is 6 meters up to this point, I know the rest must be 4 meters. So I've got 4 meters times 5, which is 20 meters squared. So my total area is 68 meters squared. Okay, and she says she has 2.5 liters in each tin, and she has 3 tins. So 2.5 liters times 3 tins gives us 7.5 liters in total. Okay, if 1 liter covers 10 meters squared, 1 liter equals 10 meters squared. I have 7.5 liters. So from here to here, I multiply by 7.5. So to work out the area I can cover, I'm going to times this by 7.5 as well. So 7.5 liters will cover 75 meters squared. Okay, 75 meters squared worth of paint is greater than 68 meters squared that she has to cover. So the answer is yes. Cool. On to the next one. She changes her mind. She says 1 liter of paint will now cover 11 meters squared. Let's see how that changes. So if I put 1 liter is now 11 meters squared. She still has 7.5 liters. How much surface area can she now cover? So again, I'm going to do exactly the same thing. I times this side by 7.5. So I'm going to times this side by 7.5 as well. And that gives me 82.5 meters squared. So the answer is no. My answer is not affected. She still has enough paint to cover the floor. Venn diagram question this time. So write the numbers that are in set P dash. Now when you see this symbol P dash, it just means not in set P. Okay, so I'm going to highlight all the numbers that are in set P, and that's going to be everything here in this circle. Everything in this circle is in set P. So therefore, everything not in set P is going to be 10, 14, 11, 13, 16, and 17. Really simple. As long as you know that notation means not in set P, it becomes really easy. Okay, question B. Find the probability that this number is in set P, U, Q. Okay, so there are 2 other notations that you need to know for probability. This means P and Q. This means P or Q. So find the probability that something is in set P or set Q. Okay, so let's go back to this. This is in set P. This is in set Q. So everything in those 2 circles is in set P or set Q. Okay, so that's 1, 2, 3, 4, 5 items. Okay, so we've got 5 out of a total of 5, 6, 7, 8, 9. So the probability it's in set P or Q is 5 of these numbers out of 9. Okay, really simple. Underline all the keywords first. She drives 513k. She pays 0.81 euros every 10 kilometers. Okay, so I'm going to round this because it wants an estimate. Every time you see estimate, you should be rounding. Okay, so I'm going to call this 510 kilometers. And then I'm going to write 0.8 equals euros equals 10 kilometers. Okay, how do I go from 10 to 510 kilometers I've multiplied by 51. So I'm going to do exactly the same on the other side. Multiply by 51. Now, this looks really complicated. It's not. We're going to use the grid method to help us with this. So I'm going to partition the 51 into 50 and 1. And then I'm just going to do this times by 10. So I'm going to call this 8. Okay. 8. 51 times 8. So because I've times this by 10 to put it in here, I'm going to divide it by 10 at the end. So don't worry about that. I've just put this arrow in to make a note. 8 times 1 gives me 8. 8 times 50 gives me 400. I add these two together, that gives me 408 euros that he should be paying. Don't forget what we said before. We multiplied by 10 here, so now we're going to divide by 10 at the end, and that gives me 40.8 euros. Okay. Is your answer to part A an underestimate or an overestimate? Well, to do that, we have to assess whether we rounded up or rounded down for each one. So let's have a look. 513, I rounded down to 510. And 0.81, I rounded down to 0.8. Okay, so this must be an underestimate. Oh, sorry, bad choice of pen. Underestimate, as values were rounded down instead of up. To find an equation of a straight line, I only need 2 coordinates. Okay, any 2 coordinates and I can find the equation of a straight line. I have 2 coordinates. I know this coordinate here, which is 0, 3. And I know this coordinate here, which is -2, 0. Okay, the equation for a straight line is always in the format y equals mx plus c. And I need to find 2 things here. I need to find myself the gradient, and I need to find myself the y-intercept. Now the y-intercept I can see straight away from the graph is just 3. So c is going to be 3. Okay, good. M, the gradient, I can find by doing the change in y divided by the change in x. So I have 2 y values here. I'm going to do 3 minus 0. This first y value minus the second y value. And then for the change in x, I'm going to do 0 minus the second x value is -2. 0 minus -2, which is 3 over minus and minus cancels out to make a plus. So this becomes +2. So my gradient is 3 over 2. So then now I have found m and I have found c. So I can write out the equation y equals 3 over 2x plus, and c is 3. This is the equation of my straight line. M is a different straight line with the equation y equals 5x. Write an equation of a straight line parallel to M. So what do we need to know about parallel lines? Parallel lines have the same gradient. So the gradient here is the value in front of the x, which is the 5. So as long as I have 5x in this, I can write whatever I want. So y equals 5x. This has the same gradient. I'm just going to add a +2 on the end for the sake of it. This 2 could be anything you want. It could be +5, could be +10, could be -7. Doesn't. Kasim having small, medium, and large jars. He has a total of 400 jars. 3/8 of the 400 jars are empty. I'm going to try and write an equation as I go for each line here. So 3/8 of the 400 jars are empty. 3/8 of 400 gives me 150. Also 150 empty jars. Okay. If I have 150 empty jars, that means I have 250 full jars. Cool. For the empty jars, the number of small jars to medium jars is 3 to 4. So that is 150. I'll write that in here. 150. S to M is 3 to 4. Okay, and then still for the 150, for the empty jars, medium to large, M to L, is 1 to 2. So I'm asked to work out the percentage that are empty and small. Okay, cool. So first, I need to combine these two ratios together. To combine two ratios together, I need to identify which variable appears in both. And here I have medium jars in both of these ratios. Okay, so now I've identified that medium is in both. I need these numbers to be the same in both variables. So I'm going to times this by 4. So these are the same. If I times this by 4, I must times this side by 4 as well. Okay, so this becomes 4 to 8. Now I know small to medium to large is 3 for small, medium is always 4, and large is always 8. Okay, and this is for 150 empty jars. Okay, I want the percentage of the empty small jars. So the small jars then, there's 15 total bits here. 15 parts total. 1 part is 150 over 15, which is 10 jars. Okay, and small accounts for 3 parts. So if 1 part is 10 jars, 3 parts equals 30 jars. Okay, so I have 30 small jars total. Now I want the percentage of the total number of jars. So I have 30 jars out of 400 total jars. Okay, he has a total of 400. So 30 out of 400. I need to make this a percentage. Okay. So this is 3 over 40. Which is, I can make this into 100 by timesing by 2.5 here. And timesing by 2.5 here. This gives me 7.5 out of 100, which is 7.5% of the total. This one. Question 8. 8 parcels. Mean weight is 2.5 kilos. So I'm going to write this as an equation now. So mean equals the sum of all the parcels divided by the number of parcels. I've just been told the number of parcels is 8. So I'm going to put that into an equation. So the mean is 2.5 equals sum over number of parcels is 8. Okay, so from this I can figure out the sum of all the parcels' weights. Okay, how do I do that? Sum equals, I'm going to move this over here, so multiply both sides by 8. 8 times 2.5 kg equals the sum of all the parcels, which is 20 kg. So all the parcels added up make 20 kilos. The mean weight of 3 of the parcels is 2 kg. So I'm going to do this bit in green. mean weight of 3 of the parcels is 2 kg. So for this bit, for these 3, the mean is, I'm going to write this out as I did here, 2 kg equals something over 3. So again, I'm going to multiply this by this. 6 kg equals the sum of those 3 parcels, okay? Which means the remaining parcels, the remaining 5 parcels, must weigh 14 kilos, because 20 minus 6, the remaining 5 parcels weigh 14 kg. Okay, it wants the mean weight of the remaining 5. So we can do that, no problem. Let me just move this up here. Okay, that's a bit ugly, but oh well. Okay, so we have mean equals the sum of the parcels, 14 kilos, divided by 5 parcels. 14 over 5, we can do this using a bus stop method. It gives us 2.8 kg. Okay, so the sale price is 70% of normal price. So how much did it reduce by? This is then 30% off. So R equals 30. Need either the x's to be the same or the number of y's to be the same. Okay, so in this case, I'm going to choose the number of x's to be the same. So I'm going to call this equation 1. I'm going to call this equation 2. For the number of x's to be the same, equation 1, I'm going to times it by 2. So I get 10x minus 4y equals 46. And for equation 2, I'm going to times it by 5, so there's the same number of x's in both. This then becomes 10x minus 15y equals 18 times by 5 is 90. So I'll put a note here of what I did. Equation 1, times it by 2. Equation 2, I times it by 5. Okay. Now I'm going to eliminate, so I'm going to do equation 1 minus equation 2. Okay, let's do that in a line. 10x minus 10x gives me 0. Minus 4y minus 15y becomes a plus. Minus 4y plus 15y equals 11y equals 46 minus 90 gives me minus 44. So now I have 11y equals minus 44. Y then equals, if I divide both sides by 11, divide by 11, y equals minus 4. Okay. Now I find y. So to find x, I'm going to take this value for y, and I'm going to substitute it into one of these. Any equation that tickles my fancy. Okay, I'm going to pick, for the sake of argument, let's do equation 2. So we'll have 2x minus 3y. Remember, y is minus 4. Equals 18. So now 2x minus 3 times minus 4 becomes plus 12. 2x plus 12 equals 18. I'm going to subtract 12 from both sides. So 2x is going to equal 6. Therefore, x equals 3. Okay, that's my quote first. Let's find triangle B. So in a column vector, the top value is my x and the bottom value is my y. So I've moved 6 in the x-axis. So I'm going to go from this point, 1, 2, 3, 4, 5, 6, and minus 4 in the y-axis. 1, 2, 3, 4. So that point moves to here. I'm going to draw the new triangle location based on that. So I'm going to go here, here, and down. This is now triangle B. Let me erase my working. Okay, there's a location of triangle B. Now for the next bit, triangle B is rotated 90 degrees clockwise, about the point 1, 2. So let's find the point 1, 2 is over here. This is my center of rotation. Center of rotation to give triangle C. So the center of rotation is here. Let's have a look. To do this, I'm going to plot a line from one point, I'm going to call it this one, to the center of rotation. So we go 1, 2 across, 1, 2, 3, 4 down. And we're rotating 90 degrees clockwise. If I rotate this whole shape 90 degrees clockwise, it's going to go to here. So I'm going to do the same again. 1, 2 down. And then 1, 2, 3, 4. This is the new location of that point. Okay. I can do this for all the points if I want to. I'm going to do that very quickly this time. Okay. Normally I don't need to do this, but I'll do it on this occasion. So here again, my center of rotation, I go 1, 2, 3, and then down 1, 2, 3, 4 to get to this point. And I'm going to rotate this whole thing again, 90 degrees. So I'm going to go 1, 2, 3 down. And I'm going to go 1, 2, 3, 4 across. So this is the second point. And the third point, I'll call that yellow. This one is going to end up here. Okay, I can draw the shape, rotate it 90 degrees, and that ends up there. So I'm going to draw the new shape, which is shape C, which is going to look like this. And then I'm going to rub out my working as I did before. Okay. Final bit of the question then, we're not finished. Describe the single transformation to get from A to C. Okay, well, to get from A to C, as we know, it has to be rotated. This one is upright, and this one is on its side. So it has to be a rotation. When we're describing a rotation, we need two things. We need the direction, is it clockwise or anti-clockwise? And we need the center of rotation. Okay, so I can see from this that this triangle rotates this way, which is clockwise. So halfway there. So we've got rotation clockwise. By how much? It's 90 degrees. And then how do I find the center point for this transformation? Okay, where does it rotate around? So I need a point that's equidistant from this point and this point, because these 2 points are the same on both triangles. If I rotated about this point, they wouldn't move. Okay, this would rotate to here. So if I go with this point, this shape would rotate 90 degrees and become this shape. So this is my center of rotation, which looks like -4, 1 as the center of rotation. Question 12. This one is about identifying graphs, and we can always do this with process of elimination. Okay. X² graphs are always smiley face. There's only one graph here that looks like a smiley face, and it's H. If it was minus x squared, it would be a frowny face. So A. But we're not being asked for that in this instance. Okay, cubic graphs. Y equals minus x cubed. So we've got two options for a cubic. They have two turning points, so it can either look like this, or it can look like this. Okay, in this case, for minus x cubed, this is positive x cubed. For negative x cubed, it's going to look like this. And there are a few graphs that fit that description. So this one falls into the category of x cubed. This one also falls into the category of x cubed. The only one that matches minus x cubed is F. Okay, good stuff. And finally, minus 5 over x. Now, minus 1 over x looks a bit like, it's called an asymptotic graph, which is where there is no y or x intercept for both of these. So y equals 1 over x looks something like this. When that's negative, it looks something like this. Because when x is 0, y equals 1 divided by 0, which is infinity, which is obviously way, way higher than our graph can go. It's impossible to display that on a graph, which is why it never touches this axis. Okay, so the only one that fits that description is J. Is drawing a histogram. Now, to draw a histogram, we need an extra column in our table. And that extra column should be frequency density. Now, to calculate frequency density, we do frequency divided by the class width. Okay. So let me just add an extra column on this table. So frequency divided by class width here, you have 20 divided by, the class width is from 0 to 10, so that's 10. So the frequency density is 2. This one, the frequency is 70, divided by the class width is from 10 to 30, so that's 20, which gives me 3.5. For the third one, it's 22 divided by 5, which gives me 4.4. You can do bus stop method to figure that out. And for the next one, we have a frequency of 30 divided by a class width of 15, which again is 2. And then lastly, we have a frequency of 8 divided by a class width of 60 minus 50 is 10, which gives us 0.8. So very quickly, I'm just going to highlight the values that we need for frequency density. Okay, I'll make it very clear. Oh, sorry. Let's make it really clear. 2, 3.5, 4.4, 2, and 0.8. Okay, now we need to plot this on our histogram. So to plot a histogram, we're going to plot frequency density here, frec density on this side, and on the other side we're going to plot whatever our variable is, which is time in minutes. Okay, so time goes from 0 to 60, so I'm going to line that up: 0, 10, 20, 30, 40, 50, 60. So that's time on that axis. Frequency density always goes on the y, and it varies from 0.8 to 4.4. So I'm just going to go 0 to 5. 1, 2, 3, 4, 5. It's really important to choose an appropriate scale for this. So make sure that your top value over here is higher than your top value in your table. Okay, now we draw. So from 0 to 10, the frequency density is 2. So 0 to 10, frequency density is 2. That's my first bit. And the frequency for this is 20. From 10 to 20, from 10 to 30, the frequency density is 70. So I'm going to go from 10 to 30. Frequency density is 3.5. So I'm going to pick a nice midpoint there. That looks okay. And the frequency for this bit is 70. Then from 30 to 35, we have a frequency density of 4.4. I'm going to do this just roughly. So 4.4 I'm going to estimate over here. And that's just from 30 to 35. So I'm going to estimate that to be there. And the frequency density for that is 22. I'll just note a 35 on there as well. Then from 35 to 50, we have a frequency density of 2. 35 to 50, frequency density 2. Should be over here. And the frequency of that is 30. And then lastly, from 50 to 60, we have a frequency density of 0.8. I'm going to estimate that to be about here. And the frequency for that is 8. So this is our histogram for that table. Okay, so that gives us our 3 marks. Now, part 2, work out an estimate for the fraction of these 150 people who are in the shop for between 20 and 40 minutes. Well, I'm going to get my highlighter out. So between 20 and 40 minutes is everyone in between these 2 points. So I'm just going to highlight between 20 and 40 minutes. That's all of these people. So the question is, how many people sit between 20 and 40 minutes? Okay. So I know we have half of this section. So 35 is half of 70. That's not a problem. We have all of this section. So that's all 22 of these people are between 20 and 40 minutes. So plus 22. Then I need to figure out what proportion of this bit stay between 20 and 40 minutes. So I have here a class width of 15. So there's 5 people here. 5 minutes here and 10 minutes here. So this is 1/3 of the way along. So I'm going to do plus 1/3, or 5 out of 15, times the 30 people that are in this section, which is 10. So I get 35 plus 22 plus 10 is 67 people. So the fraction out of the total of 150 is 67 over 150. This does not simplify. Okay, so answer is exactly as is. Only tricky bit here is that bit, to be honest. So finding the fraction of this bar of the histogram. Okay, take a step back, assess how much of it is shaded. Okay, Question 14, expand and simplify a triple bracket. Okay, we can do this really easily. We're going to do it one bit at a time. So I'm going to completely ignore this 3x minus 1 to begin with. And I'm going to just do 2x plus 3 multiplied by x minus 5. Okay, I'm going to use a grid for this. Okay, so 2x plus 3 and x minus 5. And if I multiply all of these variables in the grid, I get 2x squared in this box, 2x times x. 3 times x is 3x. Minus 5 times 2x is minus 10x. And 3 times minus 5 is minus 15, which gives me 2x squared minus 7x minus 15. Okay, so I now have this as the combination of these two, and I need to multiply by this. So my second grid is going to be for 2x squared minus 7x minus 15, and I'm multiplying by 3x minus 1. Okay, if I multiply out these brackets, this gives me 6x cubed. Minus 1 times 2x squared gives me minus 2x squared. Minus 7x times 3x gives me minus 21x squared. Minus 7x times minus 1 gives me plus 7x, then two negatives cancel. Minus 15 times 3x gives me minus 45x. And minus 15 times minus 1 gives me plus 15. Now, all the like terms, if you lay it out this way, are diagonals of each other. Okay, so I can combine all of these like terms, and I get, let's go to a normal pen, 6x cubed minus 21 minus 2x squared gives me minus 23x squared. Minus 45x plus 7x gives me minus 38x, and then plus 15 at the end. And this is my answer for 3 marks. Next bit. OAB is the sector of a circle, center 0, radius 6. Okay? So the length of the arc is 5 pi. So let's make a note of that. This is 5 pi. Work out in terms of pi the area of the sector. Give your answer in your simplest form. So I need the area of the shape. Cool. So pi d gives me the circumference of a circle, normally. Okay? Now, I don't have a full circle. I have a fraction. What fraction? X over 360. So a full circle is 360 degrees. I have X amount of degrees out of the total of that circle. So X over 360, pi d, is going to give me this 5 pi. Okay, this is the circumference of the circle, the portion of the circle I have is 5 pi. Okay, now I'm going to rearrange this. I'm going to cancel out pi on both sides, because pi appears here, pi appears here. Okay, the diameter I know is 12, okay, because radius is 6, diameter equals 12. So I get here 12x over 360 equals 5. Okay. I can rearrange this by dividing by 12 and timesing by 360. So x equals 360 times 5, multiplying this to this side, and then dividing by 12. Okay. If I do 360 divided by 12 and then times that by 5, I get 150 degrees. So x equals 150. Right, I'm going to put that in. 150 degrees. Okay, work out the area of the sector. So the area, to find the area, I need to do pi r squared. Pi r squared. And the radius I know is 6. So this is going to be 36 pi. But I don't have a full circle. Okay, this would be for a full circle. I have a fraction of a circle. What fraction of the circle, you say? I have 150 over 360 times pi r squared equals 150 over 360 times 36 pi. Now, if you notice this, the 36 and the 360 can cancel. I can get rid of this, and make this 10. Okay, so I get 150 pi over 10. I can then cancel the zeros here and here, which just gives me 15 pi over 1, which is just 15 pi. Okay, a little bit tricky with the cancelling. To be honest, you could just do the division. No problem with just doing the division, you'll get the same answer. Question 16. Probability question. There are only n orange sweets and 1 white sweet in a bag. Okay, so my total then, I'm going to write a total. I have n orange and 1 white. So my total is n plus 1 sweets. She takes a sweet from a bag and eats the sweet. She then takes another sweet from the bag and eats that sweet. Okay, so there's 2 events. So I'm going to do 2 sets of branches. There's my 2 sets. Okay, and she has 2 options. She can either go orange or a white sweet. Orange or a white sweet. Orange or a white sweet. Okay, these are the only 2 options she has. The probability of picking an orange sweet is n, because there are n oranges, out of a total of n plus 1. The probability of picking a white sweet is 1 out of n plus 1. Okay. Now, the second time, if she picks an orange sweet, I've taken away 1 orange sweet. So I now have n minus 1 oranges out of, I've taken away 1 from the total pot. So I have n left. N minus 1 over n. Okay, because I've taken 1 sweet from the total pot, so there's no longer n plus 1 sweets, there's now n sweets in the bag. Okay. If I take another one, I have n sweets in the bag, so all of these have n sweets in the bag as totals. There is still, if I took an orange first, there's still 1 white sweet left in the bag. However, if I took 1 white sweet first, there are now no white sweets left in the bag because I only had 1 to begin with. Okay, 0 over n. And there are still, if I took a white sweet first, there are still n orange sweets in the bag. So n over n. Okay, so this is my tree diagram for this model. The question states, show that the probability she eats 2 orange sweets is this. Okay, well, if she has 2 orange sweets, I need to follow this route. Orange first and orange second. Okay, and the rules of probability are, if I have 1 event and another event, I multiply. So probability O and O is multiplying them together for and. Okay, so the probability of the first orange sweet is here. N over n plus 1 multiplied by the probability of the second orange sweet is n minus 1 over n. Okay. If I multiply these together, I get n minus 1 over n plus 1. I'm just rewriting this with the multiplication. And as you can see, both top and bottom have an n multiple. I'm going to cancel these out. And this leaves me with n minus 1 over n plus 1. 17 rather. Rationalizing the denominator. Okay, to rationalize a denominator, we're trying to remove the surd from the bottom of the fraction. To do that, I multiply top and bottom by the surd, multiply top and bottom by root 7. This gives me root 7 on the top, and then root 7 times root 7 on the bottom just gives me 7. Okay, simplify fully. Root 80 minus root 5. Okay, well, root 5 is a prime number, so I can't do a lot with this. But root 80, I can split into root 16 times root 5. Now, root 16, as we know, square root of 16 is 4. 4 times root 5 is just 4 root 5. So I end up with 4 root 5 minus root 5. Now, if this said 4x minus x, we'd all know it was 3x. So we can apply the same logic here. 4 root 5 minus root 5 gives me 3 root 5s. Okay, on to the next one. Show that 0.15, both recurring, can be written in a form. Okay, so a lot of you would skip this, but I want to take it one question at a time. Okay, one part of the question at a time. Let's deal with this first as a part A, and this second. Whenever you see a question that looks really complicated, it's important that you split it into digestible components. Okay, so first I'm going to get the red number as a fraction, and then I'm going to get the blue number as a fraction. Don't try and do it together, because this is when the question becomes really complicated. Okay, so I'm going to put x equals 0.15 recurring, so both of these are recurring, so it's 1, 5, 1, 5, 1, 5. I'm then going to times this by 10. 10x equals 1.515151. Now, every time I do this, I'm going to check whether they have the same decimal. Now, I can see this decimal is 1.5 and this decimal is 5.1. So we're not quite there yet. They don't have the same decimal. So I'm going to multiply by 10 again. 100x gives me 15.151515. I'm going to do this check again. Do any of these numbers have the same decimal? And I can see this is 151515. This is 151515. So these two have the same decimal. Okay, at this point I can stop. I'm then going to do 100x take away x. 100x take away x. This gives me, both the decimals should cancel each other out. I'll show you that really quickly. 15.1515 minus 0.1515. The decimals cancel each other out, and I just get left with 15. Okay? So that's the purpose of this. It cancels the decimal, leaves me with a whole number. So 100x minus x equals 15. 100x minus x we know is 99x equals 15. So x equals 15 over 99. Okay, we've now made that red number into a decimal. And I should have done this all in red, but it's okay because I'm going to put that in a red box. Okay, let's do this one. This is now going to be the green number because I messed up the color scheme. So again, we're going to do x equals 0.2, and now only the 27, the second 27 recurs. So 2, 2, 7, 2, 7, 2, 7. I'm going to do the same thing again. 10x equals 2.272727. And then I'm going to compare the decimals. Okay, this is 227, this is just 27, so not the same. Okay, I'm going to put an x here because they don't match. I'm then going to go to 100x. 100x equals 22.727272. Again, this doesn't really match anything. This starts with 72, this starts with 27, this starts with 227. They're all different. So I'll keep going. Now I'm on 1000x. Now if I have 1000x, I have 227.272727. And now I'm going to check this again. Does this match with anything? The decimal here is 2727. The decimal here is 272727. So these two, 10x and 100x, now match. So these are the two I'm going to use here. So let's go with 1000x minus 10x equals, remember, the two decimals cancel each other out. It gives me 227 minus 2, which is just 225. So 990x equals 225, and x equals 225 over 990. Okay, let me put that in a box as well. So now I have both of these as fractions. Fantastic. We're going somewhere now. Okay, but I have to add them together. So I have 15 over 99. Remember, I have to add them based on the question. Plus 225 over 990. Now, to add two fractions, I need a common denominator. And this is really easy to do. I'm just going to multiply top and bottom of this by 10. 150 plus 225. If I add these together, this gives me 375 over 990. So I need to make this 66. We can test this in a few ways. We can divide this by 10 first. Doesn't look like it goes, but let's try it. We get 37.5 over 99. And then to get from 99 to 66, I can divide it by 3 and times it by 2. So just stick with me on this. To get this to 33, I need to divide this by 3, which gives me 12.5 over 33. And then I need to times this by 2 to get my denominator as 66. So I times this by 2, and I'm going to times this by 2 as well, which gives me 25 over 66. So m equals 25. Let's have a look at question 19 now then. Okay, we've got two similar isosceles triangles, ABC and DAB. So apparently these two are similar, this and this whole thing. Okay, AB equals AC. So let's make a note, these two are the same length. This is an isosceles triangle. And then AD equals BD. So I'm making note of that as well. This length and this length are the same. BC to CD is in the ratio of 4 to 21. So let's make a note of that. I'll put this length in blue. I'll put this length in yellow. And we'll call that 4 to 21. Find the ratio AB to AD. Okay, so let's draw this out. I'm going to draw out the small triangle first. Okay, So we have triangle A, B, C. And we know this is isosceles. And I'm going to call this length 4. Then I have this big triangle. Okay. Let's draw out the big one. And these are my sides. That's triangle D, A, B. And I know the length of one side from B all the way to D is 25. Okay, so if that's 25, this length is also 25. It's the same. Okay. This length here, I'm going to call X. And that represents the length of the base. Okay, we agree? We can see this is from A to B. This is the same length, X, from A to B. Okay. So, what can we see here? Well, the length of one side here is 25, and the length of one side here is X, and these are supposedly similar triangles. So 25 over X is the same as the base of this triangle is X, and the base of this triangle is 4. So I can write it out like this. 25 over X equals X over 4. Because these are similar triangles, they'll be in the same ratios as each other. Okay, I'm just doing this stupid puzzle because it's threatening to end my live. Okay, we're back. Right, 25 over X equals X over 4. So let's try and figure this out. Can we solve this equation? Well, if we cross multiply this, we get 100 equals X squared, meaning 10 equals X. Okay, now this could be 10 or minus 10. We only know it's 10 because you cannot have a negative length. Okay, length cannot be negative. You can't have a negative length of a side, so it must be positive. So X must be 10. Okay, is this our answer? Not yet. The question asks us to find the ratio AB to AD. So let's have a look. AB we now know is 10. And AD is this length, 25. So the ratio AB to AD is 10 to 25. Can we simplify this? The answer is yes. Both divide by 5. So it's 2 to 5 is my final ratio. Okay. Okay, now this is the end of the paper, the last maybe 3 or 4 questions, where it starts to get more difficult. Okay, we have to break these down into digestible portions, like we said. So I'm not going to look at this whole question, I'm just going to pay attention to this bit initially. Okay, so 2 to the power of n over cube root of 2. Let's try and write this as 2 separate powers. Okay, so 2 to the power of n can stay as it is. How does a 2 become this? Okay, this is the same as 2 to the power of n times by 1 over cube root 2. Okay, so this to me, to get the cube root of something, it must be 2 to the power of a third. Okay, this makes cube root of 2. Okay, because we take the root of the denominator and the power of the numerator. So this is the only way to get cube root of 2. Now, to get 1 over the cube root of 2, to get a 1 over, we have to make this power negative. When the power is negative, it makes it the reciprocal. Okay, so negative power makes it the reciprocal. So here I have 2 to the power of n multiplied by 2 to the power of minus a third. Okay, this is the bit in blue. So I'm going to put a blue box around this. That's that bit simplified. Okay, now let's look at this bit in green. So 2 to the power of y equals the square root of 2, which is what? 2 to the power of 1/2. So then we have 2 to the power of 1/2 times by 5, which is 2 to the power of 5 over 2. Okay, so from this we know y equals 5 over 2. Now we have x plus y equals 8. Let's come back to this. X plus y equals 8. And we need to find the value of n. So now we know y is 5 over 2. X plus 5 over 2 is 2.5 equals 8. So x must be equal to 8 minus 2.5, which is 5.5. Okay, so now 2 to the power of n multiplied by 2 to the power of minus a third equals 2 to the power of x. Okay, so as we know x is 5.5, and when we multiply fractions together, when we multiply indices together, we add them. We know that, I'll go down here for this, n minus a third equals 5.5. Okay, let's make this simpler. We're going to make all of this into fractions. So 5.5 we can write as the fraction 5.5 over 1. We can change this to 11 over 2. I'll tell you what, let's make it even easier. Let's make this 10 over 30. And then we'll make this 55 over 10. Just simplifying both. 55 over 10. And then 55 over 10, we can multiply that by 3. So multiply the bottom by 3 to get 30. 55 times 3 is 165. So this will be 165 over 30. So n equals 165 over 30 plus 10 over 30, which gives me 175 over 30. Can we simplify this? The answer is yes. And we can divide both sides by 5. So this gives me 6. Let's do 175 divided by 5 up here really quickly. 5 divided by 175. 5's into 1 goes 0. I carry the 1. 5's into 17 go 3. There's 2 left over. 5's into 25 go 5. So this is 35 over 6 as the value of n. Go through it slower, you can. Okay, this is question, I'm going to call this 21. Sorry, the question's cut off a bit here. But this is a cuboid with a surface area of 370. So just to make this simpler, because the question's cut off, you should do this anyway. I'll draw the cuboid. So it's going to look something like this. The length of the cuboid is 20 centimeters. So I'm going to draw this on as I go. So boom, there's 20. The width of the cuboid is greater than the height of the cuboid. So I'm going to write on here, width is greater than height. You must work out the height of the cuboid. So height of the cuboid is here. And the width of the cuboid is here. Okay, the surface area was 370. Surface area is 370 centimeters squared. Okay, let's try and write down everything we know. So, to work out the volume, it's length times width times height, which is the same as 20 times W times H. Okay, I will leave it as that for now. Do we have a value for the volume? I think I've cut off part of the question. Okay. Volume is 300 centimeter cubed. Apologies for that, I cut it off. So 300 equals 20 times the width times the height. So to find width times height, I do 300 divided by 20, I get 15 equals W times H. Okay. Funny enough, that gives me this. 15 centimeters squared. And there's another one on the other side as well. That would be 15 centimeters squared. Okay, good. So I found one part of the surface area now. So this part, the top bit, this is going to be 20 times H, this face, 20 H, and this bit on the top is going to be 20 times the width. And I have all of these faces twice. Okay, so let's write that out. Surface area 370 equals 15 twice, one face on each side, plus 20 times the width times 2, and 20 times the height times 2, because we have 2 of each of those faces. Okay, let's simplify that as much as possible. So I can get rid of this 30 from here. 340 equals 40 times the width plus 40 times the height. Okay, that's not too bad. Now, where do I go from here? I can rearrange this. Let's say the height equals 15 over the width. Height equals 15 over the width. Or I'm going to do it the other way actually. Let's say the width equals 15 over the height. I'm going to take this and I'm going to substitute that in over here. So 340 equals 40 times 15 over the height plus 40 times the height. Okay, 40 times 15 gives me 600. So 340 equals 600 over the height plus 40 times the height. Okay, I need to rearrange this now to get a height. Well, I don't like that the height is a denominator here, so I'm going to multiply both sides by the height. 340h equals 600 plus 40h squared. Okay, this all of a sudden is looking very much like a quadratic. So I'm going to make this equal to 0. 0 equals 40h squared minus 340h plus 600. And then on this bit, I can use the quadratic formula with a equals 40, b equals minus 340, and c equals 600. And if I do that, that should give me h equals, obviously it will take you a bit longer, but I've prepared it earlier. Substitute that into the quadratic formula, you get h equals 6, or h equals 5 over 2. Okay, so we need to substitute that into wh equals 15. Okay, let's have a look at that. If we substitute that in here, so w equals 15 over 6, or w equals 15 over 2.5 from this 5 over 2 thing. Okay. If it's 15 over 2.5, then w equals 6. And we know w is greater than height, so width must be 6 and height must be 2.5. Okay, so width is 6, height equals 2.5. The alternative is the height is 6 and then the width is 2.5. But because width is more than height, we know it must be this option. Okay, so width is 6, height is 2.5. Sketch the graph of y equals sine x from between 0 to 360, okay, for 2 marks. This is a really simple one to do. Everyone should be able to do this. So we're going to start at 0. We're going to mark the top of the graph as 1. We're going to mark the bottom of the graph as minus 1. And then we're going to go from 0 to 90, like this. And then back down to 180 at 0. And then at 270, it gets to minus 1, like this. And then it goes back to 0 at 360. Obviously, make it look a bit smoother, but this is the gist of the graph. Okay, so this is my sine graph. I've just got 2 marks for that, for free. Solve the equation 2 sine x equals minus 1 for between 0 and 360. So how do I go about this? 2 sine x equals minus 1. Well, if 2 sine x equals minus 1, sine x equals minus a half. Okay, so sine x equals minus a half. I'm going to look for those values on my graph. This is the graph of sine x. Where does sine x equals minus a half? So I'm going to plot here. This is minus a half. And I'm going to draw a straight line like this. I hope. And I'm looking for the points where this works. So I'm going to go up to this point, and I'm going to go up to this point. If your graph is really accurate, you'll be able to read off, which you kind of have no choice here because it's a non-calculated paper. So this gives you two answers. There's 210 here and 330 here. So your answer is, when sine x equals a half, x equals 210 or 330. Okay. If you had a calculator for this, you could inverse sine. X equals sine minus 1 here, and apply sine minus 1 to this side as well. Sine minus 1 minus a half. And this would give you the same answers. Okay, but for the purposes of this question, you must read off the graph. Okay, final question. Final question. There's a couple of you that are concerned whether you can beat a gorilla with 100 of you. If 100 of you got together, you wouldn't even be able to do this question. So get the priorities straight. Circle, center 0, 0. The equation for a circle is x squared plus y squared equals r squared. Okay, for a center 0, 0 circle. So very quickly, I'm going to draw a circle. This could potentially be awful. Okay, that's not good already. Here's my circle, center 0, 0. Okay. And we have the coordinates of P are at 5, 10. Let's make that up. P, I'm going to estimate that and pretend it's here. Okay, this is point P at 5, 10. So I'm going to mark 5. And let's pretend that's here, 10. And then the x coordinate of Q is minus 2. So if we go to minus 2, that's over here. So this is point Q. It could also be up here. One of the two. Okay, Q is either going to be there or here. I'm just going to pick the bottom end of the circle because I can. Okay. L has a positive gradient. And L, the circle C and the line L intercept at points P, Q. So I'm going to draw that line that goes through P and Q. So here's my line. It's going to go like this. Okay, this is line L. Okay. L has a positive gradient and crosses the y-axis at the point 0, k. So I'm going to call this k. And the question is, find the value of k. So the y-intercept of that line. Okay, cool. Right, we'll start with this. We have a line here with point P. Point P is 5 across, and we're going from the center, from here, 5 across, and 10 up. Okay, so let's draw that triangle. Here's the origin, here's point P, we're going 5 across, and 10 up. So we can find the radius here with Pythagoras. Okay. So 5 squared plus 10 squared, I'm going to call this the radius. 5 squared plus 10 squared equals r squared. So r squared is going to be 125. Okay. So the equation of the circle is x squared plus y squared equals r squared. So I have x squared plus y squared equals 125 as well. No problem with that. Okay. I need to find the coordinates of point Q. Point P, I have the coordinates for, no problem. Point P is at 510. Point Q, I don't have the coordinates for. All I have is an x coordinate. So I can find that because point Q is also on the circle. So for coords of Q, x squared plus y squared equals 125 because it's on the circle. And the x value for point Q is -2. So -2 squared plus y squared equals 125. Let's rearrange this then. So this is 4 plus y squared equals 125. Y squared equals 121. So y must be 11. Okay, or it could also be -11. Okay, why is Q 11 or -11? Because Q can be here, or Q can also be here. Okay, so the y value is not certain. It's either 11 or -11. Okay, if Q was at 11, it would be above P. Let's draw that on. So this is 10. If Q was at 11, it would be over here. So the gradient of QP would be negative. It would slope down. We're told here that L has a positive gradient. Okay, so because we know L has a positive gradient, we know Q can't be 11, so it has to be down here. We have to take the -11 as the value. Okay. Okay, so it must be this. Must be this for L to have a positive gradient. Okay. The devil is in the detail on this question. Okay, so we've got now the coordinates of Q as -2, -11. And we have the coordinates of P. P is at 5, 10. Now we need to find the value of K. K is the y-intercept of that line. Okay? So, to start with, the straight line always follows the equation y equals mx plus c. And the gradient then for y equals mx plus c, we can find very quickly by doing y minus y1, change in y, divided by x minus x1, change in x. So the gradient gives us -11 minus 10, divided by -2 minus 5, which is -21 over -7, which is just 3. So the gradient is 3. So to find the c value, I'm substituting that into this equation. So y equals 3x plus c. And c is going to be the y-intercept. So c is what I'm looking for here. It's equivalent to k. Okay. So I can find this by substituting in a y value and an x value. So I'm going to have 5, 3 times 5 from here, and y is going to be 10 plus c. So 10 equals 15 plus c. So c has to be -5. And c is the equivalent of k because that's the y-intercept. So k is -5.